Yes, good morning, good afternoon, my dear students. Come to the live session, all of you. So, solution chapter we are going to discuss. From that, first we have to discuss Henry's law. Yesterday, up to solubility, we are discussed, right? So now, the effect of pressure in solubility in the gases, solubility in liquids, that can be explained by Henry's law. So that can be explained by Henry's law that we have to discuss. So now Henry's law we have to discuss. So before going to Henry's law, once I will tell my name is Lakshmanarana. This is Ellen brand of chemistry. Today we are going to discuss about the solutions in the solutions Henry's law and Henry's law numerical problems that we'll discuss now. So look at all of you. What is the Henry's law? So here actually the partial vapor pressure of the gas which is present above the surface of the liquid is directly proportional to mole fraction of the gas which is present inside the liquid. What does it mean? That we'll see. So look at, for example, this is the liquid. Sir, and this liquid will be there. So it is present in the closed container. Then here gases are present. So just assume it, these are the gases. So here this is a liquid. This is a liquid. Then here pressure will be there. So pressure, in case if you apply pressure on the surface of the liquid which is present, whatever the gas will be there, then pressure increases, pressure of gases or increases, then the solubility of gases in the liquids also increases. That is called actually the Henry's law. So we can say in the form of statement, the partial vapor pressure of gas above the surface of the liquid, is directly proportional to mole fraction of the gas present inside the liquid, inside the liquid. So this is actually the statement. So what is the statement that we will write in the mathematical formation? Pressure of the gas is directly proportional to mole fraction of the gas. The vapor pressure which is present above the surface of the liquid is directly proportional to mole fraction of the gas which is present inside the liquid. Clear, my dear students? Yes, look at. So now partial pressure of the gas, it is equals to kH into mole fraction of the gas. We can take mole fraction of the gas, right? This is mathematical formation of Henry's law. So this is, we call the partial vapor pressure of gas which is present above the surface of the liquid. Then this is mole fraction of the gas, which is present inside the liquid. Then this we call Henry's constant. Henry's constant. So here Henry's constant, in case if you want to get Henry's constant equals to partial pressure of the gas divided by mole fraction of the gas. Okay, partial pressure of the gas divided by mole fraction of the gas. Actually, the mole fraction of the gas only we are calling it as the solubility. దీన్నే మనం solubility అంటున్నాం. So actually solubility of the gases can be expressed in terms of mole fractions. ఏం చెప్తా ఉన్నాం? Solubility of gases solubility of gases explain in terms of mole fraction. Mole fraction lo express chesta unnam. Mole fraction lo express chesta. Clear, my dear students? So in terms of mole fraction I told. In terms of mole fraction. Sir, solubility of the gases when it is present in terms of mole fraction, this is only we are calling the solubility. Solubility and KH both are inversely proportional will be there, right? So that means, so higher the KH value, higher KH value will be present, higher KH value, lower solubility, that you have to remember. Sir, which gas having the higher KH value, that is lower is the solubility. Then which gas having lower KH value or lesser KH value, that is high solubility, more soluble gas. More soluble. Why I told this? They will ask a question, which of the following gases are more soluble, like that they will ask. So that is what I told. So దేనికైతే higher KH value ఉంటుందో అది less solubility ఉంటుంది because of inversely proportional both. So look at now one more point in the Henry's law that we'll discuss. In case if you draw the graph in between partial pressure and mole fraction, so graph between the partial pressure of gas and versus mole fraction of the gas inside the liquid, then we can get a curve like this. So this is the partial pressure, then this is mole fraction of the gas, then we can get a curve like this. So this indicates the KH value. These are indicates the KH values where that gas particular at mole fraction, where it will be touched, that we call the mole fraction, Henry's constant. So remember, my dear students, I told that the KH value, it is equals to partial pressure of the gas divided by mole fraction of the gas. Sir, in case if they will ask units for the KH, units kanaka adiyadante, the units for the KH is actually mole fraction, there is no units for the mole fraction, right? So mole fraction ki units undav. It is a unitless concentration term. So look at, so once unitless concentration term will be there. So KH units, whatever it is, the partial pressure units, whatever it is there, KH units also same. So as same as partial pressure units you can take. So what are the partial pressure units will be? So that only the KH value of units, KH units. So what are the units are there for the partial pressure? Atmosphere is the unit, bar is the unit, then mm of Hg, right? Then Newton per meter square, then one more pascals. All these are the units for KH value. Okay, understand? So higher the KH value, you have to remember the main point here. Higher the KH value, less solubility. Lower the KH value, more soluble in the liquids. That one of the formula, what will be the formula will be there, that is the partial pressure of the gas, it is equals to KH into mole fraction of the gas. So mole fraction of the gas. దీన్ని base చేసుకొని, sir, some of the problems are there that we have to discuss now. That are previous year EAPCET questions that we'll discuss now. Note down this. Prince Dheeraj, good afternoon, sir. Hi, sir. How are you, sir? Yes, fine. Dheeraj, fine. Now we'll discuss based on the Henry's law in the EAPCET examination what type of questions they're asking, that we'll discuss now. So look at one is observe the following data given the table. Observe the following data. Observe the following data. Observe the following data. Given in the table. Given in the table. Given in the table. So that are what are the table is mentioned gas and KH values in the bar. The gases are mentioned and KH values of that particular gases are mentioned in the question itself. What are those? CO2 gas, argon gas, then one more formaldehyde HCHO, then CH4. The values of these are mentioned, that is carbon dioxide 1.67, then 40.3, 1.83 into 10 to the power of minus 5, then 0.413. Yes, these are the gases. The correct order of their solubility in the water. The correct order of solubility in water. వాటర్లో దీని సాల్యుబిలిటీ ఎలా ఉంటుంది దాని ఆర్డర్ మెన్షన్ చేశారు. సో ఆప్షన్స్ ఇచ్చారు. సో ఆప్షన్ 1 దట్ ఈస్ CO2 is more, then after hydrogen, then after CH4, then after HCHO, then after argon, like this is mentioned. Then next B, so argon, then HCHO, then CH4, then CO2, then C, HCHO, then CH4, then CO2, then argon is mentioned, then D, CO2, then HCHO, then CH4, then argon is mentioned. Look at the question carefully. Sir, 4 gases of KH values are mentioned in the question. Sir, these are the values 1.67 for CO2, then 40 for argon, then 1.83 into 10 to the power of minus 5 for HCHO, then 0.413 for CH4. I told that the KH inversely proportional to mole fraction of the gas. Mole fraction only express the solubility. Mole fraction is solubility lo manam express chestunnadi. So higher the KH value, lower is the solubility. Then here the solubility order they are asking. So lower the solubility, lower the KH value, more is the solubility. Which is the lower KH value in this case? Sir, 1.83 into 10 to the power of minus 5, right? So HCHO. So 1.83 into 10 to the power of minus 5. The very, very, very less. So which is having the less KH value, that is more soluble, right? Then next after look at, so CH4 0.413, 0.413. Next after CO2 is mentioned, that is 1.67. Then argon is mentioned, that is 40.3, which is having the higher KH value. Lower is the solubility, low soluble. Then which is having the lower KH value, that is high soluble. High soluble. So you have to remember these values or depends upon the KH values. These solubilities depends upon the KH values like this. Okay, this question actually is given in the 2025 May 2nd lo adigina question. May 2nd ki adigina question. Yes, note down the question carefully. Note down the question. Yes, my dear students. So next question, based on that numerical problem we'll discuss. Based on Henry's law itself, numerical problem we'll discuss. Yes, look at all of you. Even this is also one of the previous year question. So it is given in 2022, July 19th. July 19th అడిగిన క్వశ్చన్ ఇది. ద క్వశ్చన్ వచ్చేసి ద హెన్రీస్ లా కాన్స్టెంట్ ఫర్ ద సాల్యుబిలిటీ ఆఫ్ N2 gas. The Henry's law constant for solubility of N2 gas is N2 gas in water is 1 into 10 to the power of 5 atmospheres. The mole fraction of air is the mole fraction of air is 0.8. The number of moles of N2, the number of moles of N2 from the air dissolved in 10 moles of water, 10 moles of water at 298 kelvins and 5 atmospheric pressure is. This is the question. Sir, options are mentioned. Option A, 4 into 10 to the power of minus 5. Option B, then 4 into 10 to the power of minus 4. Then option C, then 5 into 10 to the power of minus 4. Then option D, that is 4 into 10 to the power of minus 6. This is the question. So look at the question carefully first. The question lo Henry's law constant ante KH value mention చేశారు. That is 1 into 10 to the power of 5 atmospheres. So what is mentioned? KH value is mentioned. Then mole fraction of nitrogen in the air is mentioned. The mole fraction of nitrogen in the air is 0.8. Clear? Are you getting my point? Yes. So now partial pressure of the gas. So see, look at this is the liquid. Is that visible? Yes, this is the liquid. This is liquid. Above the surface of this liquid is gas will be there. ఈ గ్యాస్ లో నైట్రోజన్ N2 వచ్చేసి 0.8 మోల్ ఫ్రాక్షన్ is 0.8. So okay, what is the partial pressure in the air? That we have to find out, because the partial pressure of the gas is directly proportional to mole fraction of the gas which is present inside the liquid. Clear? So partial pressure of the gas, in case if you want to find out, according to the Dalton's law, partial pressure of the gas equals to mole fraction of the gas into P total. Remember this formula is according to Dalton's law of partial pressure. So mole fraction in the gas is 0.8. Then P total is mentioned, that is 5 atmosphere. So P total, that is 5. Then you can get 4. So 4 atmospheres is the partial pressure of the gas. Now what is the what is the Henry's law? Partial pressure of the gas, partial pressure of the gas, it is equals to Kh into mole fraction of the gas. So partial pressure of the gas we got 4. Then Kh value 10 to the power of 5. Then into mole fraction of the gas, that we have to find out. From this, in case if you want to find out the mole fraction of the gas, that is equals to 4 divided by 10 to the power of 5. That you can get 4 into 10 to the power of minus 5. Look at. So 10 to the power of minus 5 is the mole fraction of gas for only 1 mole. Clear? But they're asking in this, they're asking this 10 moles of water. In the 10 moles of water, what is the mole fraction? In the 1 mole of water, it is actually. But in 10 moles of water. So 1 mole of water, for the 1 mole of water is this. 1 mole of water, mole fraction of this. In case 10 moles, in the 10 moles of water, so what is the mole fraction of the gas? So you have to take cross multiplication, right? That is 4 into 10 to the power of minus 5 into 10. That you can get 4 into 10 to the power of minus 4. 4 into 10 to the power of minus 4 is the answer. So don't think 4 into 10 to the power of minus 5. It is only for when the gas is present in 1 mole of water. But here the 10 moles of water is there. So when it is multiplied with 10, then you can get the answer is this. Understand, my dear students? Yes. So note down the question. Yes, next we'll discuss one more topic, that is Raoult's law. So actually Henry's law is discussed for the gases which are present soluble inside the liquid. The solubility of gases in the liquids, that we are explained by the Henry's law. But Raoult's law can be explained the solubility of solids in the liquids, the solubility of liquids in the liquids, that can be explained by Raoult's law. So this is what? Henry's law. So remember, what are the conditions for the Henry's law? You know? So ఏవైతే gases water లో soluble అవుతా ఉన్నాయో, that must be non-reacting with the solvents. So what are the conditions? Yes, is that clear? Clear, my dear students? Clear? Right. So look at all of you. Yes. So now, that is conditions for Henry's law. Conditions for Henry's law, if you take. So that is number 1. Gases which are dissolving in the water, that need not to react with, need not to react with the liquids or solvents. That is what? Gases or do not react with solvents తో react అవ్వకూడదు. Then second one వచ్చేసి, the gases must be need not dissociate or associate in the solvent. So dissociate అవ్వడం కానీ associate అవ్వడం కానీ జరగకూడదు. Gases must not dissociate or associate in water or solvent. These are the conditions which are preferred for the Henry's law. So next we have to discuss Raoult's law. So in case if we take for the Raoult's law, remember my dear students, Raoult's law is discussed solubility of liquids in liquids, then solubility of solids in liquids. So రెండింటిని డిస్కస్ చేస్తా ఉంది Raoult's law. But Henry's law డిస్కస్ చేసేదేమో for the solubility of gases in the liquids, but Raoult's law can be discussed, that is the solubility of liquids in the liquids, solubility of solids in the liquids. First the solubility of liquids in the liquids that we will discuss. So that means in case if you take a component A, that is solvent is there. So just assume it as solvent is A, solvent undi. So solvent, it contains the vapor pressure. Here the vapors are there in the closed container. Whatever the vapors are there, that we call P naught A. So దీన్ని ఏమంటున్నాం, P naught A అంటే vapor pressure of pure component A. Vapor pressure of pure component A. This is A. So A solvent, the only solvent will be there. There is no other component in it. దాని వేపర్స్ ఏవైతే ఉన్నాయో ఆ వేపర్స్ యొక్క ప్రెజర్ ఏదైతే ఉందో దాన్ని మనం P naught A అని అంటాం. సో P naught అంటే ప్యూర్ అని, ప్యూర్. దెన్ అట్లే ఇంకొక కాంపోనెంట్ తీసుకుంటున్నా, దట్ ఈస్ వాట్ సొల్యూట్. ద సొల్యూట్ ఆల్సో లిక్విడ్, ఈవెన్ దిస్ ఈజ్ లిక్విడ్, ఈవెన్ దిస్ ఈజ్ ఆల్సో లిక్విడ్. సో బోత్ ఆర్ volatile. దట్ ఆల్సో యూ హ్యావ్ టు రిమెంబర్, volatile liquids అంటే రెండు కూడా ఎవాపరేట్ అవుతాయి, volatile liquids. So this is just assume it as B. Then here the solute will be there. Even solute also can be vaporized. Then these also can accept a pressure that we call P naught B. So P naught B we call it is vapor pressure of component B, vapor pressure of pure component B. So vapor pressure of pure component B, component B. This is component here. So now when it is mixed both, mix then you can get a solution, right? Solution you can get. The solution, in the solution A component is there, then B component is there. A component is there, then B component is there. A is there, B is there. All the components are there. So once when it is present in the closed vessel, here the vapors are there. The vapors of A also is there. The vapors of B also is there. Vapors of A also is there. Vapors of B also is there. Now we call it is the PA, then PB. These are not pure. So this we call partial pressure of A. Partial pressure of A. This is PB, partial pressure of B. So these are P naught A, P naught B. When it is present in the pure state, that pressure we call P naught. When it is present in the solution state, now we call it as a solution. Why we are calling the solution? This is the solute and solvent both are mixed, so that's what we are calling it as a solution, right? Yes. So now when it is present in the solution state, so the statement now we can say, in a solution, the partial pressure of each component is directly proportional to mole fraction of that component. So note down that in solution, in solution, partial pressure of each component in solution is directly proportional to mole fraction of that component. Remember, so what does it mean? The partial pressure of each component is directly proportional to the mole fraction of that component which is present in the liquid. So in the mathematically, the statement in the form of statement we are discussing, that is, so in the mathematically, how can you express it is? ఇదే స్టేట్మెంట్ ని మ్యాథమెటికల్ గా ఎలా ఎక్స్ప్రెస్ చేస్తాం చూడండి. సో పార్షియల్ ప్రెషర్ ఆఫ్ A is directly proportional to mole fraction of A. Partial pressure of B is directly proportional to mole fraction of B. The two components are there, A component as well as B component. So both are directly proportional to their mole fractions in the solution, right? Then PA, it is equals to P naught A into mole fraction of A. Here P naught B, it is equal PB, it is equals to P naught B into mole fraction of B. So now according to Dalton's law, we know, according to Dalton's law, P total equals to PA plus PB. So P total equals to PA, nothing but what will be there? P naught A into mole fraction of A plus P naught B into mole fraction of B. So this is the mathematical formation. This is the Henry's law of mathematical formations. So both are, we call it as Raoult's law. Then according to the Dalton's law, both are equal. Partial pressures of both components are equal to that. Clear, my dear students? So note down the statement of Raoult's law and mathematical formations. Then we'll discuss one more. Here, Raoult's law for non-volatile solute containing solutions also will discuss. Raoult's law for non-volatile solute containing, Raoult's law for non-volatile solute containing solutions. Raoult's law for non-volatile solute containing solutions, that will discuss. So non-volatile solute ante it may be solid, it won't evaporate at room temperature. So non-volatile solute, nothing but, so the solute it do not evaporate at room temperature దగ్గర evaporate అవ్వని substance. Sir, for some of the example for the non-volatile substance, glucose will be there, non-volatile substance. Then urea is there, non-volatile substance. Then sucrose is there, non-volatile substance. All these are non-volatile substance. Once non-volatile substance, that is non-volatile solute is present inside the solution. It is solvent, A component is there. దీనికి B component అంటే solute and non-volatile solute యాడ్ చేసాం. So A is a solvent, then B is non-volatile solute, A is solvent, then B is non-volatile solute, A is solvent, then B is non-volatile solute. So now here the vapor pressure will be there, but here only the A component, PA will be there, but P not be, no, or PB not there. So only PA is there because A only vaporizes, B does not vaporize at this solution. Why? Because the B is a non-volatile solute. I told. Non-volatile solute to room temperature దగ్గర evaporate అవ్వదు. That is. So even in this case also we can say the statement according to the Raoult's law, that is, we can say in solution containing non-volatile solute, a solution containing non-volatile solute, partial vapor pressure of component is directly proportional to that component. That means, so partial vapor pressure of component only one is there, I told, that is A component maatrame undi. So that is PA, it is equals to it is directly proportional to mole fraction of A. Then PA, it is equals to P naught A into mole fraction of A. So general ga mole fraction of A plus mole fraction of B equals to 1 anukuntam. So from this we can say the mole fraction of A, it is equals to 1 minus mole fraction of B. You can take mole fraction of B, 1 minus. Clear, my dear students? Then PA, it is equals to P naught A into 1 minus mole fraction of B. So when it is multiplied with that, the PA, it is equals to P naught A minus P naught A into mole fraction of B. Then the negative terms in this side, then positive terms in that side. So we can say, we can write here, look at, we can write. So that is P naught A into mole fraction of A, it is equals to P naught A minus, when it is sent PA that side, then PA. Then mole fraction of, this is what mole fraction of B. The mole fraction of B equals to P naught A minus PA divided by P naught A. This is another form of Raoult's law. So what will be there? Another form of Raoult's law. Look at carefully. What will be there? What is there inside the table? What is there inside the circle? That is another form of Raoult's law. The P naught A minus PA divided by P naught A equals to mole fraction of B. So how can you say the another form of Raoult's law? So this totally we call the relative lowering vapor pressure of very dilute solution. The relative lowering vapor pressure. The relative lowering vapor pressure of solution. The relative lowering vapor pressure of solution is directly proportional to mole fraction of solute. This is another form of Raoult's law that is applicable for non-volatile solute containing solutions. So this is totally we call P naught A minus PA divided by P naught A. The total term we call relative lowering vapor pressure. Relative lowering vapor pressure equals to mole fraction of solute. The solute is non-volatile solute. This is second form of Raoult's law. Yes, note down that. So now this session will be stopped now. Again at 8 o'clock I will start. So look at my dear students, again exactly 8 o'clock I will start the next session. That are important questions which are present in the JEE mains examination or NEET examination, or we call it the EAPCET examination that we'll discuss. These are very useful for you people, those are preparing for the JEE mains or NEET or EAPCET examination. Please share, subscribe for more important information about chemistry. Then some more important topics of chemistry. So please share and subscribe my channel. Thank you.